Is that the largest I can go? Okay, can. Okay, I believe we were halfway through. We finished this one already where we looked at the differentiations between KSP, right? Then what? Ionic product and then solubility. Okay, then after that we did the first question type where we looked at if I give you the solubility, which is the concentration, can you calculate the KSP and vice versa? Meaning I give you the KSP, can you calculate the solubility of the salt for me? So things like that. So that's where we stop. Then we will continue with the rest, okay? This chapter, to me, I really feel that it's much, much easier to understand and to tackle the questions compared to X basis. But of course, if you feel differently, then good for you because usually most of the students find that exit basis is a bit tougher. Okay, yeah? Okay, can you take out this one? Let's take out this one. Okay, good. Okay, just a very quick recap. All right, your KSP, the actual full name is called solubility product. You have to get used to it, okay? Because sometimes the question will say the solubility product, then you have to know it's referring to the constant KSP, equilibrium constant. Okay, now whenever they use the word solubility, it always means concentration of the particular sparing soluble salt itself. Okay, so things like that. Then over here, for question type number 1, regardless of whether are you finding KSP based on concentration or finding concentration based on KSP, right? The very first step you need to do is always based on the formula of the salt, write out the dissociation equation. Write out the dissociation equation based, then after that you come up with the KSP expression. KSP expression means this. Look at my finger. This is the KSP expression. Okay? Yeah, because I have students who ask me, what do I mean by KSP expression? It's the same as asking you to come up with KC expression based on the equation. So it will be the formula of the product over formula of the reactant. But in this case here, don't include reactants because, very good, because if you look at, let's say for example, this equation here, this is solid equals, so we have a heterogeneous equilibrium, and based on what we learned from chem equilibrium, if we have a mixture of state symbol, we do not need to include solid as well as very good H2O. Okay? All right, so let's move on. Okay? Okay, and then we move on to the very last question type. Okay? Now, last question type, so totally there's only 2 question type here. This is the last one, okay, which is comparison question. Can you take one? You start from here, okay? Comparing ionic product with KSP type of questions here, okay? 3 scenario. IP less than KSP, then in that case you realize that the solution